Hello everyone, welcome back to Let's Talk. My name is Shivanshu Sukla and here I am with the 10th part of the running video series. This video series is not only helpful for those who are going to appear in BHU entrance exam but also for every geology student. In this part, I will solve next 30 questions of BHU PET 2019 question paper. Before starting, please do subscribe this channel if you have not done yet so that you never miss an update. So let's start from question first. Question says, a Miller indices of 0.11 means that the crystal phase. Okay, so first of all, you should know that this Miller indices is not bracketed and it strictly denotes a single phase. But if in the case this Miller indices would be bracketed, then the bracket symbol represents all the phases of a form. Okay, but in this case, this Miller indices is only for a crystal phase, therefore it is not bracketed. Now, by looking at 0.11, we can say that this crystal phase belongs to which crystal system? As option 1 is exclusive to cubic system and option 2 is exclusive to hexagonal system. So, it may belong to cubic, tetragonal, orthorhombic, monoclinic and triclinic, but this is clear that it does not belong to hexagonal crystal system. Why? Because for hexagonal crystal system, Miller symbol is HKIL. Okay, now the question is asking what can be inferred from this Miller symbol, this Miller indices. Okay, here this knot indicates that the crystal phase is not cutting A axis, or you can say it is parallel to A axis, and this 1 indicates that this crystal phase is parallel intersecting B and C axis. So, in the option 4, you will get that the crystal phase is parallel to A axis but intersect B and C axis. So, the correct answer of this question is parallel 4. But in case option 3rd, parallel to the B and C axis but intersects A axis. This means that the Miller indices would be, if it is intersecting A axis, then it represents 1 or H, and if it is parallel to B and C axis, then it will be written as not. So, it will be 1 not in the case of third option. Okay, and question is asking about 0.11. So, the correct answer is 4. Now, next question is, in which of the following crystal systems isotropic minerals occur? Okay, so isotropic minerals are those which have same properties in all direction, and all those minerals that crystallizes in cubic system are isotropic in nature. So the correct answer of this question is cubic. It is as simple. And while the minerals that crystallizes in orthorhombic, monoclinic and triclinic crystal system are anisotropic in nature, as well as these are biaxial, while those minerals that crystallizes in hexagonal and tetragonal crystal system are also anisotropic, but those are uniaxial. Okay, so as far as the question is concerned, the correct answer is cubic. Now coming to next question. So next question says, which one of the following minerals closely resembles the structure of clay minerals? Okay, so first one is sodium feldspar, second is potassium feldspar, third is muscovite, and fourth is diopside. If you look at these all four options, these all four are silicate minerals. Okay, and all these silicate minerals have a definite silicate structure. Like say sodium feldspar and potassium feldspar, these belongs to feldspar group of minerals and these have tectosilicate structure. While muscovite belongs to mica group of mineral and this belongs to phyllosilicate structure. And diopside belongs to pyroxene group of minerals and this have inosilicated structure. Now the question is asking about clay minerals. So clay minerals are also have phyllosilicate structure. Now which of the following mineral is showing phyllosilicate structure? So the correct answer is muscovite, as muscovite is showing phyllosilicate structure. You can say muscovite have phyllosilicate structure having silicon oxygen ratio 2:7. While all these three options have different silicate structure. So the correct answer of this question will be muscovite because it may closely resembles the structure of clay minerals. Okay, now next question says, which one of the following pair of minerals are polymorphs? So first of all, what are polymorphs? Polymorphs are those which are having similar compositions but having different forms, or you can say having different crystal structure or crystal system. Okay, so first pair is rutile and enantiase, second is rutile andalusite, third is rutile corundum and fourth is rutile ruby. So first of all, you should know the chemical composition of all these four minerals to check whether which of the following pair of minerals are polymorph. So first one is rutile. Rutile and enantiase both are titanium oxide, while Andalusite is aluminosilicate, Al2SiO5. Corundum is alumina oxide, that is Al2O3, while ruby is a gem variety of corundum and it also has the similar composition as corundum. In the first pair, you will say that rutile and anatase are present. These have similar composition. Only by seeing composition, you can determine that which of the following pair of minerals are polymorph. Because in case of rutile and andalusite, composition is different, so it doesn't satisfy the first property of polymorphs, that these should have similar composition. So this is not the correct pair. Rutile and corundum, rutile is titanium oxide while corundum is aluminum oxide. So this is also not the correct pair. Rutile and ruby, this is again not the correct answer because rutile is titanium oxide and ruby is Al2O3. Now, the first option is rutile and anatase. These both have similar chemical composition. So, by looking at only chemical composition, you can easily answer this question. So, the correct answer of this question is rutile anatase. Okay, next question is peridot is a gem variety of. So, to answer this question, you should know the gem variety of all these four minerals: corundum, garnet, olivine, and topaz. Okay, so corundum have more appropriately two gem varieties, ruby and sapphire. Ruby is red color gem variety of corundum, while sapphire is blue color variety of corundum. Garnet have star pyrope, star almandine, diamantite, and hazelnite as gem varieties, while olivine has peridot, which is a green transparent variety of olivine, and this is gem variety. Okay, and the question is asking about peridot. So peridot is gem variety of olivine. Now, topaz, gem variety of topaz is topaz cat's eye. Okay, so as far as question is concerned, peridot is a gem variety of olivine and it is green transparent variety. Okay. Okay, next question is which of the following ternary systems is termed as Petrogenesis residual system? So first of all, why Petrogenesis residual system? So first one is nepheline, calcite, and silica. Okay, so this is the most fundamental system related to the genesis of highly undersaturated alkali rocks. Okay, undersaturated. Now, Bowman considered that after crystallization of a primary basalt magma, the residual liquid will be highly enriched with respect to alkali, alumina, and silica, and its bulk composition should lie in nepheline, calcite, and SiO2 system. He thus called the system Petrogenesis residual system because it is originated after the residual, or you can say primary basaltic magma, crystallization of primary basaltic magma, and because of the residual liquid. Okay, and since residual liquid will be highly enriched with respect to alkali, alumina, and silica, it is termed as Petrogenesis residual system, and this system is nepheline, calcite, and silica. While if you see diopside, forestite, and silica, this may be undersaturated because these are ferromagnesian minerals, but this is not alkali. Okay, this is ultramafic, maybe belong to ultramafic, mafic or ultramafic. Now,